Good morning, class. How are you this morning? We want to look at, um, you remember we looked at trigonometry some time past, and this topic is very, very important in mathematics. Now, I'm sure at one point this was given to you. I just want to take this opportunity to explain some of the things because this topic carries a lot of marks. Now, let us look in the diagram below because we are looking at trigonometric functions. In the diagram below, the graph of y is equal to sine x is sketched, where x takes the values from minus 360 to 360. If the domain of the graph is not restricted, the domain is for all real numbers. Now, this restriction, it gives us an impression that from where are we supposed to start up to where are we supposed to end. So it is starting from 360 to 360. Take note, here we have got it's 0, 90, 180, 270, and 360 to the right of 0. And then we've got negative 90, negative 180, negative 270, and up to minus 360. When we sketch the range of the graph below, it is oscillating between 1 and minus 1. So when you sketch, you would remember you must have sketched this graph. You realize that this graph, it oscillates between 1 and minus 1, and so on and so forth. This one is for a sine graph. For cosine, is still on cosine. In the diagram below, the graph of cosine now is different from that. Is sketched, this is sketched for you from the same ranges, from minus 360 to 360. Now, and this also oscillates between negative 1, which is the minimum value, and the maximum value is 1. Now, let us look at, after this has been sketched, we want to look at the periods. Now, when we are talking about the periods, we are saying, if our graph starts here, where we have a complete revolution, right from here, the graph is still new. You can take it from anywhere. You can take it from anywhere. Now from here, we are saying the graph is still new. Here it is still new. It goes on, still new. But when we come to this point, now, when we come to this point now here, when you come to this point, this part is the same, it is now repeating. This graph is now repeating. It is now repeating. It is now repeating. And it starts once more. So meaning to say, from here to here, it has completed its cycle. And from here, it starts once more. This is what is called the period. The period, now if you say from here it's 0, 0 minus, you are saying 0 minus 360. 0 minus 360. This one is giving us a minus times a minus is positive. So the period here is 360 degrees. This is what we have. Now, same applies, this was for cosine. This was for sine. Now for cosine, you look at it as well. You can start from anywhere. If you look at this graph from here, this graph is new. If you start from here, it goes on, up to here. you now realize that the graph now, it is starting to repeat. From here, it is repeating, it goes up, up, it will turn. So meaning to say, its complete revolution, its complete cycle started from, ends here. So you are saying 90 minus 90 minus 270. 90 minus 270. You also realize this is 90 minus. This is going to give us 360 degrees. 360 degrees. So we are saying the period is 360 of this one. Now, let us go on to tangent. Tangent, it is sketched. Now, when you look at the graph, we are saying this one starts from here up to here, it repeats. So we are saying 90, so we are saying minus 90 minus 270, it gives us 180. So the period of tangent is 180 degrees. Right, we want to look at the change of amplitude. Change of amplitude. When we have the graph, you realize that the graph of sine, it oscillates between 1 and -1. In the case of change in the amplitude, the graph will multiply by A. Take note, the graph will multiply by a value. Now, here, the one that oscillates between 1 and 1, you have marked the A is 1. Now, if A is different from 1, let us look at it. On a separate axis, sketch the graphs off. So meaning to say, if you plot this point, you are saying, if A is 0, here you are starting from 0 to 360. That is 0 to 360. You are using your calculator. If A is 3, like in this case, you are saying, all right, if A is 3, you are taking the graph, here the origin, which is 0, you say sine 0. If you press sine 0 will give you 0. You multiply by 3, it will come here. You go on to 90. If x is 90, you are saying sine 90 will give you 1. Sine 90 will give you 1. 1 times 3, you plot your point there. That is where you are going to get your, this is the point that you get. Now you go on to sine 180. You are saying sine 180. Sine 180 is 0. 0 times 3, it maintains here 0. You go on to 270. You are saying sine 270. Sine 270 is negative 1. Negative 1 times 3, it will give us a negative 3 there. Now you go on to 360. You say sine 360. Sine 360 is 0. 0 times 3, it will give you a 0. That is why now you draw your graph from the knowledge that we have. You draw your graph joining those points like that. This is the graph. So on the change of amplitude, it depends. If here it is 3, so it will oscillate from +3 to -3, but maintaining the shape of sine. Same applies with cosine. If we plug in a 0 here, if we plug in a 0, a cosine 0 is 1. 1 times 2, it will give us a 1 there. Now you go on to cosine 90. Cosine 90, what does that give us? Cosine 90, it is 0. And then you say 0 times 2 still gives you a 0. You go on to 180. You are saying cosine 180. If you have cosine 180, cosine 180 is negative 1. You are using your calculator here, and then since it is negative 1 times 2, it will give us negative 2. Cosine 270 is 0. 0 times 2 still maintains 0. Cosine 360. Cosine 360 is positive 1. 1 times 2, it will give us, so the graph will be this one. If you join this one, it will be this. This will be the graph that we have from 0 to 360 of cosine. If so, meaning to say the amplitude here, it is also dependent on the value that we have here. Here we've multiplied by 2, so you have got that. Is that clear? Now let us go on to tangent. On tangent, when we are looking at, because when you plot the points of tangent, if x is equal to 0, tangent 0 is 0. 0 times 2, still the same. Now you go on to 90. On to 90, you now have, if you say tan 90, it makes error. It means to say here you have got a line of asymptote. Since you have a line of asymptote, you go on, you find other values if you plot it. So if here you have tan 90, now let us look at tan 45. On tan 45, if we look at, because the graph will still be the same, it will be the graph like this of tangent. Same applies on the lines of asymptotes. The lines of asymptotes is 90, 270, like we had on the previous one. The lines of asymptote, it's 90, 270, negative 90, negative 270. So the lines of asymptotes, they don't necessarily change there. This is what we have. So meaning to say, in this case, what happens? So the shape of the graph will be the same. The graph is maintaining. Now the standard tan graph, where a is equal to 1, has a y value of 1 at 45 degrees. In this case, a is equal to 2, and the y value, it will be equal to 2 at 45 degrees. This is why we have, it has a y value here at 2 at 45 degrees here, right? Is that clear? Now, the domain is restricted in the question. Therefore, the graph is drawn from 0 to 360. So the domain is restricted, so we cannot go beyond that. Is that clear? Now, please, on this one which we are working on, we are actually looking at, right, let us look at shifting of graphs. No, it's not shifting of graphs. Now, on a separate axis, sketch the graphs off, because now this one, it is on shifting of graphs. Now, when you are shifting a graph, you would realize that when we had a sine, because sine, we noticed that it started like this. The sine 0 was here, 90 was there, and just like that. Right, the graph of sine, it was something like this. It was this. This was the graph of sine x. But now, since we have sine x plus 1, Since we're adding a 1, you can actually see that this point has been shifted to that point, and the maximum here has been lifted onto that one. This one has been shifted to that point, and a negative 1 has gone on to 0. Each point, the same graph has been shifted 2 units upwards. 2 units upwards. That is what we have here. It is the same graph, but has been translated 2 units positively. Now, let us go on to the cosine. The cosine, it was on the cosine graph, we had it was at 1, because we have got, let me, with your permission, let me do it like this, and then I put my 1 here. For the cosine graph, let us sketch it. Cosine 0 will go on to 1. Cosine 90, it will come here. Cosine 180, it will go on to -1. Cosine 270 will be at 0. Cosine 360, it will be at 1. Now, when you look at this one, the graph is something like this. It is something like this, of cosine x. Now, when you look at this graph, let us look at it. Now, it is minus. Since it is minus, take note, this point has moved 2 steps in the, along the y-axis negatively. So it's 1, 2, it has come here. Now, this point which was here, it moves 2 steps downwards. It's 1, 2, it comes there. This point that was here now has moved 1, 2 up to this point. And this point has moved 2 steps, which is 1, 2 up to that point. This one point here has moved 1, 2 steps. That is why we have the graph here. Are you seeing it? So this is the shifting of the graph. If you have a negative number here, it is shifting along the y-axis, the number of units. If it is positive, along the y-axis, the number of units that you have. Right? Now let us go on the tangent, because you remember that one for a tangent, it was here. The one that we had for tangent, it was moving like this. It was something like this, and here it was something like that, and here it was something like that, the blue one. Now, let us look at this one. The one that we have on tangent, because this one now, because we are basically looking at the shifts along the, with your permission, let me erase this one. Right, on this one we've got tangent, now is +1. Take note. On tangent +1, the point that we had here has moved 1 unit up to there. All points, they've been shifted. In other words, it means to say our new x-axis has been shifted towards, we have had a new x-axis where we had our x-axis now, it has been shifted to this point. To this point, all points have been shifted, but the lines of asymptotes, they maintain. This one where it was cutting at 180, it has shifted 2 units upwards. This one, not 2 units, 1 unit upwards to get that. Are we clear there? Right. Now, let me go on to the other one. Now, on a shifting of trigonometric functions up and down, it means to say, now when I'm summarizing this, when we are shifting up and down, if we have a plus Q, it means to say the graph will shift 2 units, Q units upwards. If it is a minus, it will shift it will shift Q units downwards. If here we have an A, it means to say the sine graph is going to oscillate between, now if it was 1, it will oscillate between 1 and minus 1. If it is 2, oscillate between 2 and 2. If here is 3, it will oscillate between, the amplitude will just vary. If here you have a plus, it means to say this is the shifting along the y-axis, Q units. Same applies on cosine and the tangents. These are some of the sketches that we have. Now, with this one in mind, I would want us, because this is a revision of what you were given some time past, what I need from you, I want you to attempt this exercise. I want you to attempt this exercise, exercise 13, number 3 on page 366. Now, hoping that here I am recapping on what we did some time past, because this one is very important from what we have in our new syllabus that has been trimmed. This trigonometric function has a lot of marks. That is why I've decided to come back to it so that we have a clear understanding of it all. Have a good day.